So, now that we moved on to code, let me grab a drink real quick here. So now that we moved on to code, we're going to start by handling our inputs. So we're going to open up our input folder under scripts, and we're going to create a new C# script. And this C# script is going to be called keyboard input. And then we're also going to create another C# script. Okay, we'll take its sweet time here. Create C# script, mouse input. So, in this case, we have a keyboard input and a mouse input. So those are our two input devices right now. We'll in a later tutorial, I will go over how to add touchscreen and gamepad support in the future. But right now, for this tutorial, we're just going to go over how to do keyboard and mouse inputs. So let's just open up our keyboard input here. So it's going to open up Visual Studio, which is going to take a second here. I could have done this while I braked in between videos. But it gives me a chance to catch my breath. All right. So this is our C# script. If you haven't worked with C# before, if you're not if you haven't programmed before, this is going. I'm going to kind of go very quickly with C#. So the assumption is you either kind of grasp it from what I'm showing you, or you worked with C# before. I'm not going to go over every single little piece of it. For example, I'm not going to go over what a class is, or what it means by saying public class, things like that. Just know that this is a class called keyboard input. So it's an object called keyboard input, and that's all you really particularly need to know. This is a function. These double slashes mean that this is a comment. So anything that I write here never gets executed in the script itself. It's there so that I can, you can say, like, use this for initialization. Thank you, Unity Engine, for telling me that this is for initialization. So this is for start. When this is called on the creation of the script. So when you press play, the objects are all created, and then the scripts are initialized. So if we want to do something at the very beginning of something, we're going to want to use this start method. And if we want to update something on a frequent basis, we use the update method. The update method is called very quickly, once per frame. So up to 60 times per second, depending on how many frames per second your game runs at. So in this case, so update is for things that we want to happen over time, and start is just when the object starts up. So in this case, because we want to, while the player is doing things, we want to get the keyboard inputs. So in this case, we want to get the keyboard WASD keys. Now, in this case, I'm going to actually head back over to Unity real quick and point out the section for the inputs. So if you go under Edit, Project Settings, Input, you're going to see this over here in the Input Manager in the Inspector. Is going to show you that there are 18 axes, if you will. And in this case, we're going to look at the horizontal and vertical axes. Now, this is a lot of stuff right here. So let's just look at the horizontal for now. So this is the left and right movement of of your inputs. In this case, it's already mapped for you. The negative button is left, so horizontal equals -1 is left, and our positive button is right. So these are the arrow keys on your keyboard. But we want WASD. In this case, A and D are also mapped. The alt negative is A, and the alt positive is D. So in this case, they're the same. They're mapped to the same thing. You can technically use the arrow keys and the mouse in case you in case your keyboard isn't a American keyboard that has the American QWERTY keyboard that has the WASD in the correct position for first-person shooters, you can also use your arrow keys in order to move the player. So that being said, horizontal is our axis name. So if we want to get this, we're going to go back to our script over here, this one, and then we're going to go if input dot get axis, and then we're going to do open close parentheses, and inside that we are going to write horizontal. So this is stating this is an if statement, so it's asking a conditional, and it's asking whatever's inside of this if it's true. So in this case, input, I'm pulling the input class. The input class takes care of all of the things: keyboard, mouse, controller, all your input needs are handled by the input class. And in this case, we're getting an axis, as we mentioned over back here. It's an axis. So we're getting the axis named horizontal, right? And we want to know what the value of that axis is. So in this case, if I want to know if the axis does not equal 0, meaning that either positive or negative buttons have been pressed, so A or D. If that's the case, then I can say debug.log left or right. So in this case, debug.log, so debug is for debugging, that logs to the console a message that I specify. So in this case, left or right. So now if we go back over here to this, you can ignore this specific one. This is a warning saying there's inconsistent line endings. You can ignore it for now. That doesn't particularly matter. It's a problem with Visual Studio. But in this case, if I were to, say, attach our keyboard input to the player, so in this case you go over to the player, and now I have a keyboard input script attached to my player object. So including the mesh filter, mesh collider, mesh renderer, I now also have a keyboard input script. So this keyboard input script, when I run the game, so let's launch the game real quick here, I can press A and I get left or right. D gets me left or right. In this case I can collapse and I can see how many times left or right is called. Because update is called per frame, holding down A or holding down D gets me this message left or right. So in this case, I know that this code is being executed because it's showing up now in the console since I did a debug log. So now we're going to want to do something with that. In this case, we need the player's position. Now, what I mentioned earlier is that we're going to do a little bit of abstraction using a very interesting Unity trick. So we're going to before we do that, let's make a copy of this, and instead of using that, we're going to use vertical. So now I can check to see if the up or down key is pressed. So now we're going to store those in a vector2. A vector2 is a vector object that contains two floats. So it's a point, right? It's going to be an X position and a Y position. So I'm going to call this keyboard axis. Alright, and so in start we were going to want to initialize our keyboard axis. Keyboard axis equals new vector2. So this is called instantiation, and this creates a vector2 object into keyboard axis. I named it a vector2, so I need to create a vector2 object. If I were to use like a vector3, for example, that has 3 points, an X, Y, and Z, I'll get an error stating that there's no overload for vector2 in the editor. So in this case, now we've created a vector2 keyboard axis. So now in the update, I'm going to say, since the horizontal is across the x-axis, I'm going to say keyboard axis dot x equals input dot get axis horizontal. Okay, so we're also going to do something very similar for this, but instead it's going to be TICAL. That would be nice if I could spell, right? And then that's going to be a Y value. So keyboard axis X and Y are now set by the horizontal and vertical axes of the controls that we have specified, WASD or the arrow keys. So in this case, now we want this axis to apply to the player movement. Now, in order to apply to the player movement, we're going to have to get the player class. Now we haven't created that yet, so let's go back to our editor, go over to scripts here, and look at player. So in the player class, we're going to create a C# script called player movement. This is the player movement class. So this class is going to know all about how to move the player around. I just need to every time I create a new thing, it asks me if I want to reload. That's so that it shows up over here in our scripts over on the side. So right here we have our player movement class. In this case, we're not going to use start or update, but instead we are going to use a public void move. So we can call this public void move. And in public void move, we're going to take a vector2 object and call it input axis. Alright? We don't have to call it keyboard because this input axis could come from any input. For example, if you wanted to use a controller, this input axis would come from a controller input class. So, now we have our public move. So now we want to move the player. Well, in this case, we want our player to be part of the physics of the game. So basically, we want the player to be able to have gravity in order to move left and right with forces instead of translating directly left and right. So we're going to come over here and we're going to add a component, a physics component called a rigid body. Now this rigid body, if I were to run my game right now, you'll notice that, well, you won't notice it here, but over here in the transform of the player, you'll notice that the player is falling. It's going down and down and down and down into the negatives. That's because the player is actually falling. Because I've added a rigid body and the rigid body has gravity, use gravity right here, the checkbox, then when I click it, the player will actually fall out of the scene. So in order to prevent that, we're going to add a new 3D object called a plane, and we're going to move that plane over here because we want it over with us. And then we're going to move the player to the 0, 0, 0 position, and then we're going to move it slightly up so that it doesn't fall through the floor. So when I render it, or when I launch the game, the player no longer falls. That's because the plane here has a mesh collider, which allows us to. So if I were to move the player upwards, the player will now fall onto the plane in question. So now we have a ground. So in this case, we're going to call this plane the ground. And in our scene, if I back the player up a little bit, in the scene, you're actually able to see the ground right there. Now, so since we've added the rigid body, we can now get the rigid body as a component in our script. So over here in our script, we can create a rigid body object. We're going to call it rigid. And then we're going to, in the start method of our script here, we're going to say rigid equals this, which is this object, this game object that we're currently looking at, dot get component. Now the get component here, this will allow us to get a specific named component from the current object that we're looking at. So in this case, because the player movement class is going to be attached to the player, we're going to also be able to retrieve the rigid body through that. So now I can get component rigid body, and so it's going to look over this object and get the rigid body component from the player object. That way we can come down here to our move and say rigid dot add relative force input axis. Or in this case, we actually would have to go and do a new vector 3. Now, because this is a 3D game, relative force, rigid bodies, because the rigid body is for 3D, add relative force requires a 3-dimensional vector, up, down, up, forward, and right. So it has 3 dimensions, but our input is only 2-dimensional. So in this case, we're going to have to create a new vector 3 every time and call this x. And then we're not moving by the y value, we're not moving up and down, we're just moving left and right, and forward and backwards. So we're going to move this by 0, and then we're going to add a z component. So this is going to be input axis dot x, or sorry, y. So our z component is our ws, so or our input axis y value is ws. So these are our forward and backward, so we want them on the z-axis. If you have a difficult time with which axis is which, the z-axis is the one that goes forward and backwards. The x-axis is the one that goes left and right, and the y-axis is the one that goes up and down. This is a little bit different than this is a little bit confusing for people who are used to 2 dimensions, because the y value, even though the y value is up and down, in 3D space, up and down is literally up, whereas it's not just up on the screen, it's up in world space. So in this case, because our input is 2D, we're going to want our x and our z-axis to have our inputs. So this would allow us to press the inputs and add a relative force to our object, meaning pressing W or D or up or down on our arrow keys would allow the player to move forward or backwards. So let us go over to our keyboard input. We now need the keyboard input to send the message over to the player movement class, because we get our inputs and then they do nothing. So in this case, we need to send these inputs over to the player movement class, and that's why we made it a public void move. So we need this public value. I'm not going to go super into what it means to be a public function, but this function is public, so it's available to outside objects. So in this case, we also in our keyboard input class, we're going to need a reference to the player movement. So the keyboard input needs to know where to send the inputs to. So in this case, we're going to have a player movement. We'll call it player, right? So because we're sending it to the player, and so in this case, we're going to go player.sendMessage. And since we know that the message is called move, the function is called move, we're going to go move. We're going to send that message with our keyboard axis. So that's the value that we're sending to it. So that's this right here, this input axis. That's the value. So we're sending it the keyboard axis as the value. and then we're going to do something called send message options. So in this case, this is not a requirement of this, but we can choose whether or not the target object has the receiver, and we care about whether or not we care that if it has a receiver. In this case, we definitely care that the input reaches the player. So we're going to require a receiver. So now that we have our message, it's going to take our keyboard access and to send that to the player. Now we also have to make sure that this is retrieved from the player. And so in this case, in our start method here, we're going to go player equals, just like before, this dot get component player movement. So this will search this get component method will search our object, our player, for a player movement script, and then get us a reference to it, so that when we actually send the message later, then this message actually reaches our player. So let us go back to our game, our Unity. So let's go back to Unity real quick. And then in our player, we're going to go back and add a new script. So we're going to add that player script to the player, drag it up here to the player, and now you'll see that the player movement script is now applied. So now that the keyboard input and the player movement script are both in the same object, and the player movement script and the rigid body are in the same object, we should be able to move the player with the keyboards. So let me move this up here. So in this case, we should be able to walk forward towards this edge here by pressing, oh, sorry, I left out a line here. Null reference exception. So let's find that real quick. Assets keyboard input. So object reference not set to an instance of an object in update at line 24. So let's look here. So this is a good example of how to debug this. So this is line 25. So it's probably this one right here. I think it's because I didn't save the script. So let me double check here. I forgot to hit Control S before I left. Yep. So now I'm not getting that error anymore. And so here's the window, and I should be able to walk by pressing. Ooh. Oh no! What happened? So if you can see here, you'll look over here at the thing. The capsule has fallen over, and I can actually move the capsule left and right by pressing the button. But eventually, it will just roll off the edge, and now we go into a spiral forever. So what happened? Well, in this case, it's because the capsule that we're talking about has a rigid body. This rigid body has rotation. So rotation is allowed by the object. Well, a player doesn't just fall over when it walks forward, always. Sometimes sometimes people trip. But so in this case, I want to, there are these constraints values. So I'm going to want to actually constrain this to the X and Z rotations. So what that means is I don't want the player rotating over the Z axis, so I don't want the player falling on its side, and I don't want it rotating over the X axis. I don't want it falling on its face. The reason I don't freeze the Y rotation is because I do want the player to be able to rotate this way. I do want it to be able to rotate over its Y axis, which is its up and down. I want it to rotate over this pole, its Y axis. So I'm not going to freeze its Y axis. So this time when I run it, you'll see that I'll be able to move forward. Oh, come on. You know you want to. I think it's because I don't think I applied enough force. Give me one sec. So in this case, we're not applying enough force. I do know that this is actually working, and I am moving but we're not applying enough force. The friction between the two objects, the ground and the player object, is too much, so I need to push it really hard in order to get it to go anywhere. So in this case, we're going to create a new variable inside our player movement class. It's going to be a type float, so it is a floating point variable, so it has decimal places. I'm going to call it movement force equals, we'll say 10. So now, instead of only moving by, the force, adding relative force of 1 or 1, I'm going to multiply this by our movement force. This means that I will be doing a force of 10 instead of a force of 1. Now, before we move on, I'm going to actually make this a public variable. Now, again, not going into too much, but now that it's public, I will be able to see it from outside classes. And in this case, part of the Unity engine is that any public variable on a script is visible in the inspector. So you'll see over here we have our player movement script right there, and that player movement script has a movement force 10. So I can actually now manipulate the movement force here in the editor if, let's say, the player doesn't move fast enough or the player moves too fast. So we can try to test this out. So now that I have it up, I can press W to move forward, and then S to move back, and then I can move D to move right, and then A to move left. And it's, as I said, with the arrow keys, it's the same thing. So the player is now actually moving around the field, and you can see that list over here in the scene. You can see that I can move over, and I can move back, and I can move forward. So you can see that the player is actually moving around. Ugh, I almost fell off the edge. So now that I have the movement, now we want to look at how to look around, because obviously the most interesting part of a game is not always just moving, but being able to look at something. In a first-person shooter, if you could only move in straight lines, if you could only move straight forward and left and right, but not turn, you would probably lose pretty quickly. So in this case, we're going to want to work with the camera. So I'm going to do the next step is going to be the camera. So this is going to be the most complicated part of the tutorial. So I'm going to walk through it as slowly as possible, because I want to make sure that everybody kind of gets what's happening in this case. Obviously, before with the movement script, it's very simple. I'm adding a relative force, so depending on how the object is turned, I'm adding a relative force. So if you're sitting here facing forward and I press forward, you move forward. If I turn, I press forward, I move forward. I'm adding a relative force to whatever the turning is. So in this case, this is a very simple concept, and getting the keyboard inputs is very easy. Getting the mouse inputs are just as easy as getting the keyboard inputs. In fact, we just replace horizontal with mouse X and mouse Y. But once we get those values, what we have to do with them is much more complicated. So I'm going. If you want, take a break. This is where I would say take a quick break, mental break, if you will, before moving on to the next tutorial.